Mr. Davies' dose of science. If this is your first time learning with us, welcome. If not, welcome back. Hello, everyone. It's Mr. Davies back with your dose of science. I do hope you're doing well and you're feeling healthy. For today in science, we're going to take a look at the difference between mass and weight. Of course, Canvas is going to be your number one resource. We will take a quick look at a PowerPoint slide or two. We will look at the packet, do some reading on pages 12 and 13. And this is what you should be seeing when you log into Canvas. We've already looked at a couple of these items. For the packet, you can find that right here, the PDF document. And if you look at that packet, it looks something like this. Make that a little bigger for you. The first couple pages are all about vocabulary. Specifically today, the word mass is going to be pretty important. Okay, so certainly zero in on that. As we move forward, the word volume, we'll talk about that tomorrow. And then finally density. So as far as the word mass, let's take a look here. And I'm just using the first couple of slides in one of your PowerPoints in your module. I'm going to freely admit that most of the slides on this particular PowerPoint will be used next week. So don't worry about this entire PowerPoint. What I do want to focus on is the idea of matter. Last week we talked about matter and its interactions. So you should understand that matter refers to anything that has mass and takes up space. So in order to fully understand that definition, you need to understand what mass is. Mass is the amount of matter within an object. In order to measure mass, we use a balance. So hopefully that helps you understand a little bit more about mass. We're going to go back to the packet and learn by reading. I'm going to be using pages 11, 12, and 13 in the packet today. So if you want to go back later and review that, you can. As we finish, you should be able to use what you know about mass to explain the word massive. And you should be able to identify something that is heavy, but not very big. When we want to know more about something, we often measure it. For example, will the new table fit through the kitchen door? You can measure the width of the table and the width of the door to find out. Or, imagine that you've packed your suitcase for vacation. It looks massive, but the airline only allows suitcases under 50 pounds. Will you need to take some things out? You could weigh the suitcase and find out. Measuring requires tools such as balances and rulers. Scientists use special tools like the ones shown below to measure things. Measurements can be taken in different units of measure. Scientists usually use the metric system. The metric system is also known as the International System of Units, or SI. Units of measure in the metric system include meters, liters, and grams. Now they're showing you two different tools here. They have graduated cylinders on the left. These are typically used to measure liquids and powders. On the right, you have a spring scale, and it's labeled as a Newton scale, which is used to measure weight. As we continue, You should realize that mass and weight are not the same. As we continue through this section, you will find out how mass and weight are different and learn how to measure both. At the end, you should be able to summarize. What is the difference between mass and weight? Mass and weight are often confused. Mass is the measure of how much matter makes up an object. Weight is a measure of the gravitational attraction between the mass and another object. When we step on a bathroom scale, we weigh ourselves. Gravity is at work. The scale actually measures the gravitational attraction between your body and the Earth. Gravitational attraction depends on the masses of the two objects and the distance between them. In fact, if you weren't so close to the Earth, the gravitational attraction wouldn't be as strong. You wouldn't weigh as much. Mountain climbers weigh less at the top of Mount Everest than they do at sea level. This is because they are farther away from the center of the Earth. Similarly, astronauts weigh about 1/6 of their Earth weight on the Moon. This is because the mass of the Moon is much less than that of Earth. The weight of an item depends on its nearness to another object and the mass of that object. In space, humans weigh less, though their mass stays the same. Measuring for weight and mass. Notice that weight is labeled on the left, mass is diagram B on the right. The following example shows how weight and mass are different. The scale, shown in diagram A, is used to measure weight. It shows that the bag of beans weighs about 13 pounds. On the Moon, though, the same bag of beans weigh a bit more than 2 pounds. The measuring tool shown in diagram B is different. It is a balance, which is used to measure mass. On one side are the beans. To balance the beans, a 6-kilogram weight is needed on the other side. This means the beans have a mass of 6 kilograms. On the Moon, the two pans would balance only if the same 6-kilogram mass was used. The Moon's gravity acts on the beans, the mass, and the metal in the same way. The mass of the beans is 6 kilograms no matter where they are measured. There are different kinds of balances, but they all work the same way. An unknown mass is balanced by a known mass. The object, whose mass is unknown, is placed on one side. Masses of known amounts are placed on the other side until the two sides balance. Then, the known masses are added together. This is the mass of the unknown object. Okay, if you're looking for some additional activities to complete, there's a really good 2-question activity right here. How would you use a balance to answer those questions? All right. I'm going to take a look back at Canvas at this point and point out a number of videos that might be very helpful to you. I also want to point out that the difference of weight is essentially the gravitational field. So different gravity fields would produce different weights. Some of the videos that point that out, and I would definitely encourage you to watch them. First one is the mass versus weight introduction video. This video is brought to you by NASA, and it involves a number of astronauts on the International Space Station talking about the differences of mass and weight. Next is a mass and weight cartoon. This one's a bit more entertaining. You will have to do some reading to understand that, but I think that's a really good follow-up. And finally, is mass the same as weight? This was a student-created version from a different area of the country, probably a 8th or 9th grade student, but they did a pretty good job. So I've included those 3 videos for you to reinforce the learning for today. Mass and weight introduction, mass and weight cartoon, as well as the Is Mass the Same as Weight student-created version. Don't forget to submit your assignments on Canvas. All assignments are due by 8 p.m. on Friday. As always, please stay healthy, stay safe. Until next time, this is Mr. Davies. Have a great day and keep on learning. If you learned something today, please like this video. If you think there is more you can learn, then click subscribe or consider coming back again tomorrow. The information, likenesses, and opinions in this video are the intellectual property of Mr. Mike Davies. While Mr. Davies does refer to other works owned by others, those resources are either parts of a public school district curriculum or they are readily available through open forums on the internet. Mr. Davies does offer his thanks and appreciation to any entity he has chosen to refer to or gather sound bites or clips from to emphasize his lessons. Mr. Davies is currently a professional member of the teaching staff for Central Dauphin School District in Harrisburg, Pennsylvania, and is making, producing, and publishing these videos for the benefit of his students and other students during the current lockdown crisis. Mr. Davies does not make claim to all of the ideas and resources referenced in his videos. However, he does claim responsibility and rights to his likeness, opinions, and the academic content of these videos. He does not grant permission for any entity to copy or duplicate any portion of this video or any of his videos for private or personal gain.